Okay, so this tutorial is going to go through how to get started with this practice 7.2, which is the very last page of the day 3 packet. For this, you are going to need your day 2 packet with the notes. You're also going to need that colored one pager with the different notes on that, polyatomic ions, the common acids and bases, as well as the solubility table, which we're going to talk about in this video as well. First thing to know with this practice is really what we're going to be doing. So it says that you're going to be determining what the reactants are if you're given the names. And it kind of reminds you here, acids are on the colored reference sheet. So if there's something that's mentioning acid, you're going to need to reference this list down at the bottom of your one-pager document to see what that would actually be as a compound. Okay. And then it says you're going to determine what the products will be. So we're predicting that. We have to figure out what this chemical reaction is going to be making based on the hints that were given in the description. So we'll take a look at what that means. The other thing we're needing to do is include the states of matter for each product and reactant. The ones here are given to you in terms of what you're starting with, and then we're going to predict what would happen in this reaction using what we know about these compounds. And then you are going to use this sheet, again, that was printed in color, to make sure you're checking for those diatomic elements. So when those are by themselves, those ones that are highlighted in blue, those will always exist as a set of two when they are alone. It's going to be different when they're bonding with something, but when they're alone in the reaction, they're going to exist as a set of two. So like N2, O2, so on. Then you, with checking the solubility, this is mainly going to apply to our double replacement reactions. So we're going to take a look at one of those examples specifically. But this solubility table is really easy to use because all you need to do is line up, and actually I'm going to try to see if I can get it on my, I'm going to pull it up on my other screen here as well, so I can kind of show you where I'm looking. So let's say I wanted to figure out if, like, I don't know, barium carbonate was going to dissolve in water. So I'd find barium, I'd find carbonate, and then I'm just going to follow their path across. So then I see that this like intersection of the two says that these two would be a solid. So it's not going to dissolve in water. Okay, no matter what, it wouldn't be aqueous. So all of those other ones that are AQ, that represents it's aqueous and that it would dissolve in water. Some of these elements, like no matter what they are bonded with, they are going to be aqueous, like potassium. You can look all the way across. Nitrate is one of those polyatomic ions that's very soluble in water. And then there's a couple of other ones that are very soluble as well. There's not a lot that it doesn't dissolve with. Ammonium is another one where there's just one thing, like when it's with hydroxide, it's not soluble, but every other combination it would be. So there's just some things to note with that one. So we're going to be checking that and kind of using that, but really it only is going to be super important to use this with a double replacement reaction. Everything else, it's pretty obvious what's going on in the reaction for us to know what it's going to create. So we'll take a look at that today with what we're working with here. All right, so I'm gonna go back into the packet. Super. Okay, then once you have this all written out, then you are going to be balancing each equation. How you decide to do that is up to you. You can use a chart, you can use the pictures, however you want to do it. You're also welcome to use like the bingo chips that I have in the classroom. They're on the shelf underneath the television, just on the lower shelf. Just please make sure you put those back when you're done, so that I don't have little bingo chips all over the floor. And then what you can do is, like, if you balance it out on those whiteboards, you can just take a picture of it with your iPad and insert that picture onto your practice. Oh no, wait, you can't do that with this because you're not doing Notability. You could just save it. That's fine. Save it as a picture and then just put a note for yourself on your worksheet here, like solved with the bingo chips, like picture in camera roll, whatever you want to do. That's totally fine because I'm not collecting this today, obviously. All right. Let's take a look at some of these examples here then. So there's only 5, which means we have one of each reaction type that we're going to be looking at here. I want to start with number 3 because that's the one that's most different from what we've been looking at. So we are told that we have aqueous lead nitrate, and that is reacting with, lead 2 nitrate, and it's reacting with aqueous hydrochloric acid. So I'm thinking in my head, okay, acid, that's what I'm going to need to check that period, or that one pager for that information. So I'm looking here where I'm seeing common acids and bases, and I'm looking for hydrochloric acid, which is just HCl. So I'm just going to write that on here so I don't forget what that is. And then this lead 2 nitrate. So lead 2, that's telling me that I have lead with a 2+ charge, and it's bonding with nitrate. Now this ATE, that tells me that that is a polyatomic ion. So I'm looking up into the chart here, and I see that nitrate is NO3 with a 1- charge. So NO3, 1-. So I've got all the information I need for my reactants. And I've got that I know that they're aqueous, both of them. So I'm going to write those out first and just kind of see what this is giving me. So with my lead and my nitrate bonding together, I'm going to have 2 nitrates for every 1 lead because I need that compound to be balanced to 0 with the charges. So I'm going to have Pb, and then I need my NO3 in parentheses, and I need 2 of those. So that, remember that 2 outside the parentheses is saying that I need 2 of whatever's inside the parentheses there. So Pb is, there's just 1 of those, and then I have 2 nitrates with that. And that's aqueous. I'm going to put an AQ here. And then this is reacting with aqueous hydrochloric acid, which is just HCl. And again, I'm adding that state of matter of AQ there. Okay. Now, this, I have to figure out, okay, what type of reaction is this? What is this going to be making? What's happening here? So thinking about, and this is where your notes from yesterday are going to come in hand. Okay, so you're going to need to use that. So we have here 2 reactants that each have 2 components to them, right? With this nitrate, we typically tend to treat those polyatomic ions as one part of the compound. So I've got lead, nitrate, hydrogen, and chlorine. And we want to predict, okay, what is going to happen on the other side of this equation based on what I have reacting here. So remember, our equations all follow specific patterns, typically seen with those ABs or A, B, C, and Ds as just a general pattern that it follows. So what you'll need to do is look in your notes and figure out what type of reaction this would most likely undergo, and then you're going to check that with Edpuzzle. All right, so you should have figured out that this is a double replacement reaction because we've got each of these compounds with 2 components. They're basically going to swap partners on the other side. So my lead, which is positive, is going to go with my chlorine, which is negative because hydrogen has a +1, chlorine has a -1. So on the right side of my equation for my products, if I have lead and Cl, I'm going to have Pb Cl2 plus, and then hydrogen is going with the nitrate. So that is just a 1-to-1, so that's going to just be HNO3. And now I have to figure out here, we have to remember, we have to get the states of matter that these are going to be in. So I've got my reactants, I've got my products, and now I want to make sure I'm including the states of matter with these. So I have to look at what I've got here. So I need to use that solubility table to see how lead and chlorine bond with each other, and then how hydrogen and nitrate bond with each other. So I'm going to look at the solubility table, and I'm going to look for lead. This is lead 2, and then I need to find where chlorine is, which is right here, chloride. So lead 2 chloride. So again, I'm following across, following down, and I'll show that on here as well in case that's not showing up the way I want it to on the video. So lead 2, and then chloride. and that is in fact a solid. So that is not going to dissolve in water. So then underneath that one, we need to specify that this will be a solid. So this is what we call a precipitate. Okay, now for the other one, we need to check that as well. So H and then nitrate. So again, I'm looking at my solubility table. Oh, duh, nitrate. So this is one that would, this one bonds with everything. So this one, it doesn't matter what it's bonded with. Everything, single thing it connects with is going to be aqueous. So go back to this one. This will be AQ. All right. So, and this is a big thing because if this had not created a solid, we really wouldn't have had anything happening because it would have just been like aqueous, 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 aqueous. And those ions wouldn't have done any, like there would have been no chemical reaction happening. So in this case, because we have a solid forming, a precipitate, that means that there is definitely signs of a chemical reaction. So we're good to go there. All right, next step is to, so we've checked solubility. We don't have any diatomic elements in this case because there's nothing by itself. And then the last thing to do would be to balance it. So you'll need to kind of go through that strategy of, balancing out your elements. I'm not going to model how to do that on here just to make sure that I can get through the examples that I want to get through. But we should have plenty of examples of how to balance within the videos you've watched or the practices that we've done previously. Okay, the other one I want to look at is, which one was it again? Oh, number 1. Okay. So lithium nitrate. So it says solid lithium nitride is heated. There is presence of a gas being released during this process. So we're going to start by figuring out like what our reactants are. So we have lithium nitride. So I have Li and N. Neither one of those is polyatomic. They're just going to be in our chart here. So I'm looking at, again, at that charge for each of those. So lithium has a +1 charge. Nitrogen has a -3 charge. So I'm adding that to my notes here. So when I want this to balance, I'm going to need 3 lithiums for every 1 nitrogen. So I'm going to have Li3N. And I know that that's solid because it told me that here. And if it's being heated, it doesn't say anything about it reacting with something. Heat is not an element. That's just our energy that's getting added to our reaction to get this to happen. So this is just going to turn into something here. So that tells me that this would be what type of a reaction? Okay. Hopefully you decided that this would be not combustion, goodness gracious, a decomposition reaction. So it's decomposing, that heat is getting added to take apart those different components of our molecule or of this compound of lithium nitride. Now what this is going to turn into are just those component elements. So we will have lithium and nitrogen. So lithium is a metal, so that would be a solid. And then it says there is presence of a gas. Well, nitrogen is a well-known gas. Most of these, actually no, all of our elements on this side of the periodic table for the most part are gases. So that's how we would know that. So nitrogen is going to be our gas. Okay. The other thing is we do not want to forget about our diatomic elements. So nitrogen is one of those diatomic elements. So we don't do anything to it when it's bonded over here on the left, but when it's a product by itself, we need to write it as a set of 2. So it's N2, and that's a gas. Okay. So we've got our reactants, we've got our products, we've got our states of matter. We took care of that diatomic element there. We don't need to worry about solubility because none of this is aqueous. And then the last thing to do would be to balance this equation. Okay, so you've got those 2 examples there. The rest of them, again, use those generic equations of these different chemical reactions to determine what type of a reaction it is based on what you're seeing in the setup for the beginning part with the explanation that's being given to you. When you are creating your compounds for your reactants, make sure you're referring to those charges. Like your charges need to balance to be 0 when you're writing that compound. So just like what I modeled with the lead 2 nitrate and the lithium nitride, where I'm figuring out those two charges and then balancing it in the compound to get the charges to balance to 0. Okay, so all those little things we have to keep in mind and consider as we're writing those equations out. So you should have enough information now to get started. If you have questions, try to lean on each other, look at what other people are, see what other people are doing, how they're solving these. And you can even look back at your previous unit's notes if you're really, really stuck. Otherwise, that ultimate one-pager that I gave you guys, a couple weeks ago now, but you probably have it in Notability, has on the second page how to name compounds or how to write the compound based on the name. So it's a really messy flowchart, but that should be pretty helpful if you're super stuck with the naming of those compounds. Okay. Other than that, I think you should be set for this. So you only have 3 left to do, as well as like balancing all of them. But we've got that because a lot of you were saying that was really easy, so that's good to hear. All right. Good luck.